Okay, so in this video, we're going to talk about how to calculate molar mass and why it's important. So molar mass, or sometimes also called formula mass, is the mass that is found in grams of 1 mole of a compound based on its chemical composition. So if we look at the formula for a compound and we add up the weights of each of the elements in the compound based on how many atoms of that compound there is, that's what the mass is. And this is the mass of 1 mole. Finding formula mass is really important anytime you're doing stoichiometry and you're doing a conversion where you are asked to find the grams of a substance, or if you are in grams and you're trying to convert out of that unit, you're going to have the molar mass of the compound in order to do that. So it is a very important skill. It is something that when you're doing stoichiometry, first thing I always check if you get the problem wrong is, did you calculate the molar mass right? The more that we do of these, the more cocky we get, and the more we think we can just do it in the calculator and not write it down. And that's where like really silly mistakes come in that make you get things wrong. So make sure you're paying attention with calculating molar mass and being very careful. All right, so what are our steps here? Our first step is break the compound down into its elements and determine the number of atoms of each element. Then find the atomic mass of each element on the periodic table. And step 4, multiply the number of atoms by the atomic mass. And finally, we total it up. So we're going to go through 4 examples. So let's look at our first 2. So for the first one, we have C6H12O6, which is glucose. So I'm going to break this down into its parts. So glucose is made of CH and O. I have 6 C's as noted by the subscript. I have 12 H's and I have 6 O's. Okay, then I need to go to the old reference packet and I need to get the atomic mass of each of those things. So for carbon, the atomic mass is 12.01. So I'm going to write that down, 12.01. For hydrogen, my atomic mass is 1.008. 1.008. And for oxygen, my atomic mass is 16.00. Don't be lazy and write that down as 16. It has sig fig implications that will come back to haunt you later. So make sure that you're writing it all down. All right, so now I need to do some math. I have 6 carbons. Each of them has a mass of 12.01, so 72.06. I have 12 hydrogens, each with a mass of 1.008, so 12.096. And I have 6 oxygens, each with a mass of 16.00, so 96. Don't let the calculator screw you over, 96.00. All right, and then total them up. So 72.06 plus 12.096 plus 96.00, grand total of 180.156. So when I'm using this as a conversion factor, what that means to me is that 1 mole of C6H12O6 has the mass of 180.156 grams of C6H12O6. That is a very useful conversion factor. Remember, I can use it in both directions. Okay. All right, so let's look at the next one, aluminum sulfate. So Al, S, and O. So I have 2 aluminums. Then I need to look at my formula for the sulfate. I have 3 sulfates, and each sulfate has 1 sulfur and 4 oxygen. So 3 times 1 is 3 sulfurs, and 3 times 4 is 12 oxygens. All right, then I need to go back to my periodic table. Aluminum, 26.98. And sulfur, 32.07. And we know oxygen, because we already looked it up, 16.00. Believe it or not, by the end of this unit, you will be quite proficient with remembering what the atomic masses of a bunch of elements are. Not all of them, but the ones you use all the time, you'll know. So 2 times 26.98 53.96, 3 times 32.07, 96.21, and 12 times 16.00, 192.00. Add that up. So 53.96 plus 96.21 plus 192.00 gives me 342.17. So I can write that as grams per mole with the understanding that's 1 mole. I can write it as 1 mole Al2SO43 is equal to 342.17 grams Al2SO43. Again, lots of practical uses of finding molar mass. All right, next one, potassium phosphate. So K, P, and O, 3 potassium, 1 phosphorus, 4 oxygen. So for potassium, 39.10. For phosphorus, 30.97. And again, we know oxygen, right? 16.00. So let's start doing our math. 3 times 39.10 gives me 117.30. We don't need to multiply this one because there's only one. And 16.00 times 4, 64.00. Add them all up. 117.30 plus 30.97 plus 64.00 gives me 212.27 grams per mole. Okay. And our last one, HNO3. So HNO. One of those, 3 of those. All right, hydrogen, 1.008. Nitrogen, we need to look up, 14.01. And oxygen, 16.00. So 1.008, 14.01, 16.00 times 3, 48.00. Add those all up. 63.018 grams per mole. All right, so that process, again, anytime you are in grams doing stoichiometry or asked for grams, you're going to have to find molar mass to be able to do those conversions. Make sure you don't rush through it and make silly mistakes in your calculator.